So our Newton's second law, what is Newton's second law?
F equals ma.
F equals ma. But our target, the thing we want to start at, is a. So we're going to say a is f net over m. That's my size, my writing size. Good. What is that? A is a derivative of something.
Velocity.
With respect to?
Time.
Nice. And that's, what's our F net? mg minus bv. Don't forget there's a, oh no, there's not. That's a, not ma. A equals f net over m. Here's my f net, and I need my m. So that tells us dv dt is g minus bv. What does this really mean, this equation? What does dv dt represent? It's a ratio. A ratio of something. What does the d stand for? The d is for difference. For a difference of v, we have a difference of t. Each little bit of t that goes by, a little bit of v changes. That makes sense? And the proportion of those changes is equal to g minus bv. So I could separate that equation and say, how do I get a little bit of change dv? Well, each time a little bit of time goes by, a tick of the clock, if you will, dt, I get this much change, g minus bv times that dt. Change in v is acceleration times time, is all we're saying there. So how could I solve that to find velocity as a function of time? What will this look like? Let me copy it if I can. Do I know how to do that? I'll just rewrite it. dv equals g minus bv dt. I want a little more space. dv equals, tell me if I get it wrong, g minus bv times dt. So you fall out of an airplane, starting from rest. What's your initial velocity? So how much will this term matter to start out? It won't. So if we graphed v versus t, like you do, what would the initial behavior be? I need like a hand so I can cover up this term. I need a virtual hand. What would the equation look like if v is 0? So v equals 0 implies dv dt equals g. dv dt is the what of the v versus t line?
Slope?
The slope. Perfect. So initially we'd have a slope of g. That makes sense? What's the initial value for my velocity? 0. So what would the beginning of this graph look like? Starts at 0 and then does what? Will velocity increase as the skydiver falls? At what rate? 10, like that. So slope here equals g, approximately 10. Remember, we're taking down to be positive. That's why this thing's going up. Because I'm saying it's like the speed. Are the units of any slope on this graph going to equal the dimensions of the vertical axis over the dimensions of the horizontal axis? The dimensions of this vertical axis, since it's a speed, are meters per second. The dimensions of the horizontal axis are seconds. Since a slope is a rise over run, do the units have to be meters per second over seconds? Yeah, that makes sense. Now, we said, what's going to happen to the size of the drag force as she falls faster and faster? It gets bigger. It gets bigger until what happens? Which things equal out?
The velocity.
Good. The acceleration becomes, she doesn't accelerate anymore. Good. So that's when the weight equals the drag. What will the velocity be when that happens? Can we solve that? What is it? If a equals 0, that means g minus bv equals 0. Is that true for all v or for a particular value of v? Particular value. What is that particular value? We can call it v terminal. But if you solve for it, what does it equal? Ah, this isn't a. This is f. So I need an m here. mg minus bv, right? I saw that the units were wrong there. So this is mg over b. Oh, by the way, can you tell what the units of b must be? If you can figure that out, talk to the person next to you or think on paper. What must the units of b be? So the units of that g term, meters per second squared, must be the units of, I'm going to use square braces to mean units. The units of b times, what's v? Meters per second, and m is kilograms. So the units of b are, did my meters cancel here? And I've got a 1 over seconds and a 1 over seconds squared. So that leaves us with a 1 over seconds here equals b over kilograms. So the units of b are kilograms per second. That, you agree?
Yeah.
What is a Newton, by the way? Kilogram meter per second squared. So could I relate this to newtons? I feel like I'd like to do that since it is a drag force coefficient. So I see a kilogram and a second are accounted for already. So I need this is the same as a Newton second, is that right? A Newton times a second would give me a kilogram meter per second. A Newton per second meter. Newton second per meter.
Wouldn't it be meter per second? Oh, no. Okay, I get it.
So a Newton is a kilogram meter per second. So this is a kilogram meter per second squared times seconds over meters. I cancel my meters and I cancel 1 second, gives me a kilogram per second. Good. So Newton second per meter, or a Newton per meter per second. So I flipped this fraction and put it in the denominator. Why does that make sense? It's force per speed. And is that what drag is? The force per speed, because the more speed you build up, the more force you get. So V terminal, you told me the value here. What is V terminal? What does that mean?
That's the maximum velocity before the stop accelerating.
So if we graph that here, V terminal, our actual solution should not cross this line. Does that make sense?
Yeah.
Now, actual motion, is it choppy or smooth usually? So does it make sense what we're looking for? I'm imagining a function. It starts with this slope. It's smooth. And it asymptotes to this value. What does it mean to asymptote?
Like go in the direction but never reach it.
Yes. Constantly approaches, but never reaches this asymptotic value.
Will never reach its velocity.
Right, but it will get arbitrarily close.
That's
So,
the limit. That's the limit of it.
Yes, exactly. It's the limiting value. So if I took the limit of this function, velocity, as a function of time, as time becomes big, time goes to infinity, the value is V terminal.